You will have in lesson 28 a variety of word problems involving geometry, physics, and also economics. So that leads me to the next problem. Question 6. A certain bakery has found that the daily demand for bran muffins is given by the function 33,600 over P as in Paul, where P is the price of a muffin in cents. The daily supply is 11P minus 100. Find the price at which supply and demand are equal. That last sentence tells us how to set up our equation or set up our problem. Supply is equal to demand. So supply is represented by the expression 11P minus 100. And demand is the fraction 33,600 all over P. Eliminate the fraction by multiplying both sides by the denominator. On the right-hand side, the p's cancel. And on the left side, we distribute that p times everything in parentheses. So that would give us 11p squared minus 100p equal to 33,600. Now, in order to solve this quadratic equation, move all of your terms to one side so you have a 0 on the other side. So we'll subtract 33,600 from both sides. And that gives us now 11p squared minus 100p minus 33,600 equal to 0. Now, I don't know offhand the factors of that large number, so let's use the quadratic formula instead. So the quadratic formula is P equal to negative B plus or minus the square root of B squared minus 4AC all over 2 times A. In which A is 11. B is negative 100, and C is negative 33,600. So we have our letters labeled properly. So plug all of our letters into our quadratic formula. Now, at the very beginning, the quadratic formula is B is negative, and our B is also negative. So we have a double negative at the front. And we can make that a positive 100. Plus or minus the square root of negative 100 squared minus 4 times A, which is 11, and times C, let me zoom out so you can see everything, times C, which is negative 33,600, all over 2 times A, or 2 times 11. Now let's calculate the discriminant, or everything under the radical. So negative 100 squared is 10,000. And when you multiply your last 3 numbers, you get 1,478,400. And when we add that number to 10,000, that gives us, under the radical sign, 1,488,400 all over 22. Before we continue, any questions about the setup or plugging everything into the formula? Actually, the number inside the radical, this is a perfect square root. This is 1,220. And anytime we're left with just numbers, no radicals and imaginary parts, we must split this with the plus minus sign to get our 2 possible answers. So over here we have 100 minus 1220 all over 22. And you could reduce this to lowest terms if you want. But really there's no need to, because profit, just like time and sides of a shape, profit, well, it could be negative, but we're looking for how much we would have to, how much the muffin would have to be in order for us to get a maximum or positive profit. So we can reject negative 560 over 11. And let's see what the other answer is. P is equal to 100 plus 1220 all over 22. And that gives us 1,320 over 22. And again, since the price must be positive, I misspoke earlier. Yeah, profit can be, you can be in a negative situation, but P represents price, and that cannot be negative. So that's why we rejected the negative 560 over 11. So in order for supply to equal to demand, the price of a muffin must be 60 cents. Any questions about this economics problem? Another question you'll encounter in applications of quadratic equations is a problem involving distance, rate, and time. So let's look at number 7. In 5 hours, Carrie can travel 27 miles up the river and come back. The rate of the current is 4 miles per hour. Find the rate of her boat in still water. So we'll let X represent the boat's rate in still water. Now, anytime you are dealing with distance, rate, and time, draw a table. So let's see, 4 by 3. 1, 2, 3, 4. The first column, we can just label our directions, going up and then coming back down. At the top of the table, we're labeling using our distance formula. So we have D for distance, and R for rate, and T for time. We need to solve our distance formula for T, actually. So to solve for I got my symbols backwards, I'm sorry. At the top, that should be distance equal to rate times time. And we need to solve for T or get T by itself. So we'll divide both sides by R. So when we get ready to label time for each trip, we have to put the respective distance over each rate. Now, regardless of whether Carrie traveled up the river or down the river, her distance was the same going up and down. So distance is 27 miles. Now, to find the rate for each trip, if Carrie is going upriver, then that means she's going against the river's current and losing speed. So we can represent Carrie's rate going up as X minus 4. Coming back down, Carrie is going with the current of the river. So with the current means she's gaining speed, and we know that's addition. Now, to get the last column, time, we have to take each distance and put it over each rate. So for up the river, that's represented by the fraction 27 over X minus 4. And down the river, the time is represented by the fraction 27 over X plus 4. Any questions about the table before we set up our equation? All right, we use the information in the last column to set up our equation. The time traveling up the river plus the time traveling downriver and the trip going up and the trip going down the river, together that took 5 hours. So we set our equation equal to 5. Now, anytime we have fractions in an equation, we need to get rid of them. So the common denominator would actually be both denominators. So we'll take x minus 4 times x plus 4 and multiply each part of our equation by that least common denominator. Including the right side. In the first fraction, the x minus 4's cancel, leaving us with 27 times x plus 4. And tell you what, we can go ahead and distribute that 27. So 27 times x is 27x. And 27 times 4 is a positive 108. For the second fraction, the x plus 4's cancel. And when you distribute that 27 times x minus 4, 27 times x is also 27x. And 27 times negative 4 will give us negative 108. On the other side, nothing cancels. So we just multiply the x minus 4 and x plus 4. So that would give us, when you FOIL out, x minus 4 times x plus 4 is x squared minus 16. And when we distribute that 5, we get 5x squared. And then 5 times negative 16 will give us negative 80. On the left side, we can combine our x's, giving us 54x. And the 108s actually cancel. And let's bring down the right side of the problem, of the equation, excuse me. I'm going to stop again. Did any campus or off-campus have any questions? Now, in order to solve this quadratic equation, we need all of our terms on one side and 0 on the other side. So let's subtract 54x from both sides. Now I'm going to lift this up so you can see the rest of the steps. On the left side, we have 0 equal to 5x squared minus 54x minus 80. Now, if you tried to factor this quadratic equation the regular way, you couldn't do it. There are no factors where you can break this down into two parentheses. So we have to use our quadratic formula. And I'm going to put the rest of the steps up here, and I'll just explain these to you. We have to use our quadratic formula, in which A is 5, positive 5, B is negative 54x, and C is negative 80. So we plug those values carefully into our quadratic formula. The quadratic formula's B is negative, and our B is negative, so we have a double negative happening in the front. So that changes to a positive 54. Plus or minus the square root of B squared, which is negative 54 squared, minus 4 times A, which is 5, and times C, which is negative 80. Now, when you calculate the discriminant under the radical, negative 54 squared is a positive 2,916. And when you multiply the last three numbers together, that gives you a positive 1,600. And that's all over 2 times A, or 2 times 5. Now, when you put the radical in your calculator, unlike the last problem, this radical is not a perfect square root. And let me show you with my calculator how we got these answers. With my calculator, I can enter the fraction just like it is. 54 plus square root of 4,516. And then divide that amount by 10. And I don't think the directions told us to round to a specific place value, so we can just carry this out to 2 decimal places. So one possible answer is 12.12 miles per hour. Now, because we have the plus minus symbol in the middle, then we need to find the other answer. So when we plug in 54 minus the square root of 4,516, and then divide that by 10, we get negative 4.32. Rate cannot be negative, just like negative time or negative negative sides. So we reject the second answer. And our only answer, the speed of the boat in still water, is 12.12 miles per hour. Any questions about this particular rate problem? Okay, the last example in lesson 28, before we do lesson 29, is a work problem. Work, W-O-R-K, I'm sorry. Two pipes are connected to the same tank. When working together, they can fill the tank in 10 hours. The larger pipe working alone can fill the tank in 15 hours less time than the smaller one. How long would the smaller one take working alone to fill the tank? All right, so for the smaller pipe, it can work 10 hours with unknown time. We'll let X equal to the time it takes the smaller pipe to work alone. Now, together with the larger pipe can complete the job 10 hours, and it can do it in 15 hours less time than the smaller pipe. So its particular rate is X minus 15. Now we need to figure out what our equation will be equal to. These pipes are working together to complete one job. So our equation is equal to 1. Now, eliminate the fractions. The common denominator is actually X times X minus 15. So that's what we'll multiply each part of our equation by. For the first fraction, the x's cancel. And when you multiply that 10 times x minus 15, 10 times x is 10x. And 10 times negative 15 is negative 150. With the second fraction, the x minus 15's cancel, leaving us with just 10x. And on the right side, nothing cancels. So distribute that x times x minus 15. So x times x is x squared. And x times negative 15 is negative 15x. Back on the left side, combine your 10x's. So that would be 20x minus 150 equal to the right-hand side. Now, we have a quadratic equation forming, but we need to move all of our terms to one side in order to solve it. Well, because x squared is positive over there, let's move all of our other terms to the right side. So we'll not only subtract 20x from both sides, but we will also add 150 to both sides. And we now have 0 equal to x squared minus 35x plus 150. Now, before we solve this quadratic equation, any questions about the setup? Now, this quadratic equation can be factored, but you can also use the quadratic formula to break it down and find your answers. But this will break down to x minus 30 times x minus 5 and when you solve for each x, you can either set each binomial equal to 0 or you can do opposites. The opposite of a negative 30 is a positive 30. And the opposite of a negative 5 is a positive 5. Now, in your homework, before you move on to the next question and think we got the correct answers, you have to test each answer to see if it makes sense. So if we plug in 5 into the first denominator, well, that's okay because that will give you a positive time, 5 hours. However, if you replace x with 5 for the larger pipe, that will give you 5 minus 15, or negative 10 hours. And as y'all know, time cannot be negative. So that means reject positive 5. Just to be on the safe side, test 30 as well. So when we plug in 30 for the smaller pipe, that's a positive time, 30 hours. And when we plug in x for the larger pipe, 30 minus 15 gives us 15 hours. So it's good on, checks out, it gives both pipes a positive time. So in conclusion, it takes the smaller pipe 30 hours when working alone. Before we do lesson 29, are there any questions about lesson 28?